Ever feel like your phone is juggling like a million things at once? I mean, right now I'm browsing, listening to music,
Right.
and I bet my smart speaker is off somewhere, quietly queuing up my grocery order.
Yeah.
It seems like magic, doesn't it? Having all this happening seamlessly at the same time.
It might seem like magic, but it's actually a really clever trick of computer science called parallel processing.
Okay,
And once you grasp the basic idea, it's surprisingly intuitive.
let's unpack this. What's the secret sauce behind parallel processing?
So imagine you're a lumberjack in desperate need of a massive amount of wood.
Okay,
You could wait decades for a single giant tree to grow.
right.
Or you could plant a whole forest of trees that would be ready to harvest much faster because they're all growing simultaneously.
Okay, I see where you're going with this.
Yeah.
So instead of one lumberjack going after like a giant redwood, it's more like a whole team working on smaller trees at the same time.
You got it.
Okay.
And just like that team of lumberjacks, your devices use parallel processing to break down complex tasks into smaller, more manageable chunks called threads.
Okay.
Instead of one super powerful processor trying to tackle everything at once,
Right.
these threads are divided up and worked on simultaneously by multiple processing cores.
So each of those smaller tasks, those threads, is picked up by a different processing core.
Exactly. It's like having a whole team of workers inside your computer, each with their own specialized job to do.
Okay.
And just like a skilled foreman manages their team, your operating system acts as a conductor, making sure all these threads are efficiently assigned to the different processors to keep everything running smoothly.
Yep. Right.
It's a bit like a complex dance, but when it works, it's a thing of beauty.
This is already blowing my mind, and we're just getting started. But okay, we've got the why of
Yeah.
parallel processing. Breaking things down makes them faster. What I'm really curious about is how it actually works in those tiny computers we carry around. How can a computer with like a single brain run multiple processes at the same time?
That's where things get even more interesting. You see, before we had these multi-core processors, computers relied on a clever illusion.
Okay.
They would switch between different tasks so rapidly that it seemed like they were happening simultaneously, even though it was really just one processor doing a very fast juggling act.
So kind of like a chef juggling multiple dishes at once. They're not literally cooking everything at the same moment, but they're switching between tasks quickly enough that it seems like it.
That's a great analogy.
Okay.
Think of a chef constantly stirring the sauce, then checking the oven, then prepping the garnish, all in rapid succession. It looks like they're doing it all at once, but it's really just very efficient task switching.
So that's how older computers managed to multitask even with just one processor. But then came the real game changer. Multiple processing cores. It's like suddenly having two chefs in the kitchen instead of one.
Exactly. Each core is essentially an independent brain that can handle its own thread.
Okay.
So now, instead of just rapidly switching between tasks, your computer can genuinely process multiple things at the same time.
That's wild. It's like upgrading from a one-man band to a full orchestra. But I imagine it takes a lot of coordination to make sure all those cores are playing in sync and not stepping on each other's toes.
Absolutely. And that's where the operating system really shines.
Okay.
It's like the conductor of this technological orchestra, making sure each instrument plays its part at the right time.
Right.
It manages and distributes tasks to the different cores, striving for peak efficiency.
Wow.
To borrow another analogy, it's a bit like air traffic control for your computer, ensuring everything runs smoothly and no data collides in midair.
Right.
Most of the time, anyway.
Right, because we all know what happens when technology has one of those off days. But it's mind-blowing to think that this intricate dance is happening behind the scenes every time we use our devices.
It's easy to take for granted, isn't it? But this concept of parallel processing isn't just some abstract computer science theory. It's happening all around us, constantly shaping our digital experiences.
Wait, are you telling me my phone is basically a parallel processing powerhouse?
You got it. Your smartphone, your laptop, even that smart TV you're streaming this on, they all rely on parallel processing to function.
That's incredible.
Think about it. Those stunning graphics in your favorite video game wouldn't be possible without parallel processing.
Right.
Neither would that crystal clear video call with your family across the globe. Parallel processing is the invisible engine powering it all.
My mind is officially blown. It's like realizing there's this whole hidden world operating beneath the surface of everything we do digitally.
Yeah.
And to think, I used to get impressed by simple multitasking.
Well, understanding parallel processing can actually change the way you think about technology.
Okay.
It helps you appreciate the sheer complexity and ingenuity behind even the simplest actions on your devices.
It's like getting a backstage pass to how it all works.
Right.
Instead of just being a passive user, you become more of a, well, maybe not a collaborator, but at least a more informed spectator.
I like that.
Yeah.
And who knows, this newfound understanding might even spark a curiosity to explore the world of programming.
Okay.
After all, programmers are the ones who harness the power of parallel processing to create all the amazing software experiences we enjoy.
Now that you mention it, I am a little curious about how programmers actually use parallel processing. It sounds incredibly complex, like trying to write a symphony for a room full of musicians playing different instruments at the same time.
Yeah.
It does, doesn't it?
Yeah.
It takes a special kind of mindset to think that way.
Right.
Instead of seeing one big task, they see all the individual threads, all the different pieces that need to come together in harmony.
That's a very poetic way to put it. And you're right, it can be a complex dance.
Yeah.
Essentially, programmers have to write code that can be divided up and run concurrently on those different cores.
Right.
It's like choreographing a team of dancers to move independently while still creating a unified performance.
So instead of one dancer trying to do all the steps at once, you've got multiple dancers, each with their own part. And when combined, it creates something even more intricate and amazing.
Exactly. And the results can be pretty incredible. For example, think about editing a massive video file.
Okay.
Without parallel processing, that rendering process could take hours, maybe even days. But with parallel processing, the software can split that task up between all available cores, dramatically speeding things up.
So less time staring at that progress bar, willing it to reach 100%. I can definitely get behind that.
Precisely. And it's not just about making things faster, it's about expanding what's even possible. Those incredibly detailed and immersive video games we talked about.
Right.
Parallel processing is a big part of what allows developers to create those lifelike graphics and complex physics simulations without your gaming console turning into a molten mess.
It's like magic, but powered by lines of code instead of spells. So what you're saying is that parallel processing isn't just about doing things faster. It's about pushing the boundaries of what we can even imagine doing with computers.
You're catching on.
Okay.
And this is really just the first act. As processing power continues to grow, and as programmers come up with even more inventive ways to utilize parallel processing,
Right.
who knows what incredible things we'll be able to achieve.
Okay, now you're getting me really excited about the future.
Yeah.
What kind of impossible tasks might become possible thanks to this technology?
Well, it's exactly. Or picture architects and engineers using parallel processing to design and test intricate structures in virtual environments,
Right.
pushing the limits of what's possible in construction and design.
Okay.
We could see buildings that seem to defy gravity or bridges that span unimaginable distances.
It's like parallel processing isn't just making computers faster, it's expanding the realm of what we thought was possible.
That's a great way to put it. And it's all happening behind the scenes in the devices we use every day.
Right.
The next time your smartphone effortlessly switches between apps, or you load a complex website in the blink of an eye,
Right.
take a moment to appreciate the invisible army of processors working in concert to make it happen.
I'll never take my phone for granted again. So to sum things up, parallel processing is all about breaking down complex tasks into smaller ones, assigning them to different processors, and letting them work their magic simultaneously.
And this elegant solution is what allows our devices to be faster, more efficient, and capable of accomplishing things that would have seemed impossible just a few decades ago.
It's like we've gone from a horse and buggy to a supersonic jet in a relatively short amount of time.
And the journey is far from over. As we continue to develop even more powerful processors and innovative algorithms, who knows what incredible destinations await us in the future of computing.
Well said. It's enough to make your head spin a bit, but in a good way. It's like peeking behind the curtain and realizing that even the most mundane tasks are powered by this incredible dance of data and processing power. It makes you appreciate the ingenuity of the human mind, doesn't it?
It certainly does. And who knows, maybe one of our listeners will be inspired to join the ranks of those pushing the boundaries of parallel processing and contribute to the next big breakthrough.
Now, wouldn't that be something? But for now, we'll leave you with this thought-provoking question. What seemingly impossible problem do you wish could be solved with the power of parallel processing? Think about it, and until next time, happy diving.